Okay, so let's start out with a simple example. We have a molecule here which only has one central carbon and then two carbons attached and two heteroatoms. We'll call it nitrogen and an oxygen, but it can be anything attached. And you can see now with this molecule, the interesting thing is we have a plane of symmetry on both sides of this molecule, and it's a little hard to tell, but on both sides of the molecule, we have, let me get my hand out of the way, we have essentially the same elements, okay, on both sides. Try it from here, on both sides. I hope you can see there's a plane of symmetry. So that's achiral. That molecule does not have handedness. Any molecule that has those constituents will be superimposable on it. Now, let's say we do this. We have a molecule that has, instead of having three different substituents, I put this on here. Now I've got a molecule that has in the central carbon 1, 2, 3, 4 different substituents on it. Okay. Now, in this case, we have, is that molecule chiral? Well, hope you can see, no matter how you try to look at it, you cannot find a plane of symmetry. Okay, you cannot bisect the molecules such that both halves are equivalent. So that is a chiral molecule. And the interesting thing about a chiral molecule is we can make kind of a buddy to it. And let's see what this buddy looks like. This buddy has, this is a stereoisomer in a sense that, let's see how it relates here. Okay. Is it the mirror image? No, it's not the mirror image. Oh, this is the identical molecule. Okay, so these are two chiral molecules that are identical. Okay, if I had a mixture of these type of molecules, that would be homochiral mixture. All right, all the same molecules with the same stereochemical positioning. Okay, actually, that's a good thing. Now, let's say I was to switch two of the atoms in this molecule. What do we have? Well, let's see. Now, lo and behold, we see we have mirror images of the compound. These are two enantiomers, which are mirror images. Okay, they cannot be superimposed on each other. And a drug that's a mixture of those two stereoisomers would be called a racemate. Okay, 50-50 mixture is called a racemate. And I want you to remember that a racemate is really a mixture. Now, why does it matter? That's a question that I really want you to ask yourself. Who cares anyway? Well, you care, and I'll show you why. I have my little friend here, Mr. Ducky, and I had to put this little piece of green on his face here to make this demonstration work. But you could see that he's got kind of a red and a blue and a green attachment point. He's a little rubber ducky, but he's going to be our receptor or our enzyme stand-in. So here he is, and we want to see how he would react with a molecule. Well, let's try this one here. Oh, okay. In fact, I'm going to start with the other one. Let's see. These two, now this compound here, will it work? Will we get a way that we can attach this guy? Actually, no. I think I had it backwards. This guy will not bond properly. How about this guy here, the other enantiomer? Okay, let's see. That's got to be a way. How am I doing this wrong? Ah, there we go. Now we've got Mr. Ducky, where each point of the receptor, the duck, is bound to the corresponding atom of the attachment molecule, the ligand, okay, or the drug. So you could see how one enantiomer would interact favorably with this receptor or enzyme, where the other enantiomer, there's no way I can spin this molecule so that I can get all 3 points of attachment to line up. They won't. I've got the green here. Now if I put the red in the green, no, there's just no way that the enantiomer will match. That's the way it is molecularly. It's similar to saying I have a glove here, and this is a right-handed glove. I have a right hand. Okay, you can see how the right hand fits very nicely in a glove, no problem. But if I take my right hand and try to fit it into a left-handed glove, well, as you might imagine, that's just not going. I've got my pinky finger where my thumb is and my thumb where the pinky finger is. That doesn't work because the gloves are handed and my hands are handed, so they have to match in the proper way. Well, virtually all receptors and all enzymes have that handed quality, and they have to interact with the appropriate enantiomer of a drug that has a stereochemical center. Okay, I hope that's helpful.